All right, guys, in this video, we're going to go over the other two operations with complex numbers. So if you watched part one, we looked at addition and subtraction with complex numbers. So really just combining like terms when you're doing that. Multiplication and division are a little more complicated. We'll start with multiplication. Kind of the key thing you guys need to know for multiplication is when you're doing this, you want to make sure that you know that I squared, as we talked about in our last lesson, I squared is the same as -1. All right, so it's going to happen a couple times or every time pretty much when you multiply. And if that does happen, we're going to change that I squared to be a -1. All right, let's multiply these first two here. So when we have 3i times -8i, I'm going to multiply the 3 times the -8 and get -24. And then I times I is going to be I squared. All right, and like we just mentioned, I squared is the same as -1. So I'm going to go ahead and rewrite that as -24 times -1, which becomes a positive 24. So notice we started the problem having that letter I, right, the imaginary piece. And when we finish this problem, it's actually just a whole number, right, just a real number. No imaginary pieces anymore. All right, the next one, if you wanted to, you could write as 2 minus 7i times 2 minus 7i, or you could expand like we did in Unit 1, where you take the first term and you square it. You take the second term and you square it, which is plus 49i squared. And to get the middle term, you do the first term times the second term times 2. So that's going to be 2 times -7i is -14i. Double that, and you get minus 28i. Okay? Now, like we mentioned earlier, whenever you see that I squared, you have to continue the problem because that's actually going to be a real number. So that's times -1. So 4 minus 28i minus 49. Do 4 minus 49, which is -45 minus 28i. All right, so that is going to be our answer for part B. Okay, let's do the next one here. The next one is distributing this 5i onto the 3 and onto the 2i. So 5i times 3 is 15i. 5i times 2i is going to be plus 10i squared. Now watch what happens here, right? We had 15i, just bring that down. I squared is the same as -1. So that's going to be 15i minus 10. And I want you guys to always think about how you write this. We're going to write this in the form of the real number and then the imaginary piece, right? So complex numbers are real and then imaginary. So to finish this, we're going to write -10 plus 15i. All right, so just get in the habit of always doing that where you put the real component first. One more, and then we'll get to division. All right, this last one here, I'm just going to multiply these first two, and that's going to be -7i squared, all right, which is actually going to be -7 times -1, or positive 7. All right, now I'm going to bring down that 4 minus 3i. So I'm going to distribute that 7 times the 4 and the 7 times the -3i to get 28 minus 21i. And that's it for that one. Okay, so that's how we do multiplication. Now, if you have enough practice multiplication and feel confident with that, and that's okay if you don't just yet, but as you practice that, you're going to realize that as we move to division, if your multiplication skills are solid with complex numbers, you're going to be just fine with division. Because you're going to see once we get doing these problems that really division with complex numbers is just kind of two instances of multiplication. All right, so let's talk a little bit about something called complex conjugates. So we talked about in the last video of a complex number being a real part, right? That's the real piece. And this here is the imaginary piece. All right, so we always do the real and then the imaginary. Okay, so the complex conjugate of a plus bi is going to be a minus bi. And the complex conjugate of a minus bi is a plus bi. So when I'm asking you guys to find out complex conjugates, I'm asking you to keep everything the same except for the sign in between your real and your imaginary piece, right? And the reason this is important is because if you were to multiply these complex conjugates out, so if I distribute, I get a squared minus abi plus abi minus b squared I squared. All right, now here's the interesting part. If you look at the middle two pieces, right? These are going to make 0, all right? And then this a squared is going to be a real number. But watch what happens with the b squared I squared. So b squared is just going to be a whole number. And then we said I squared is the same as -1. So again, this is a whole number, and that's going to be plus b squared. So the idea here is that when you multiply these conjugates, you basically get rid of the imaginary piece. All right, so no more letter I. And the reason we do that is because we have to use complex conjugates to get rid of those I values, right? I is the square root of -1. And when that's in the denominator, you guys learned in Algebra 1 that you cannot leave radicals in the denominator. All right, so essentially when you see the letter I know you don't actually see the radical when you see the letter I, but you should know what I represents. And because we have that radical, we have to do something called rationalizing the denominator. So to do this, we're going to multiply by complex conjugates. Okay, long-winded way of showing you here now. So what I'm going to do first, when I look at this, is I'm going to multiply the top and the bottom by the same conjugate. And you always do the conjugate of the denominator. The goal here is to get rid of that I in the denominator. That's the most important thing. So you copy the 2, copy the 3i, and then the sign in the original denominator is subtraction. So the sign for the conjugate is going to be addition. Whatever you put in the bottom, you have to put in the top, all right? Because otherwise you're going to change the expression. All right, so now it's up to you on if you want to do the denominators first, denominators second, doesn't matter. I usually do the denominators first. That's going to give me my new denominator. All right, and for this first one here, and probably for a lot of these in class, as we're starting to do these, I'll go ahead and multiply everything. But as we showed up in the notes just above this, essentially I really just need to multiply the first and the last, right? Don't have to do the oi in oil or in FOIL because that's going to become 0. So 2 times 2 is 4. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. There's that thing that becomes 0. Negative 3i times 3i is minus 9i squared. All right, so as I mentioned earlier, right, this should become 0. That's on purpose. You shouldn't be surprised by that. 4 minus 9 times -1 is really 4 plus 9, which is 13. So this right here, 13, is my new denominator. Okay, let's multiply the stuff on top. So these two up here, so that's 5 plus 3i times 2 plus 3i. Now this one I'm not expecting to get rid of my imaginary piece, right? When I'm doing my denominators, I know I'm going to get rid of my imaginary piece, but here I'm probably not going to. So 5 times 2 is 10, 5 times 3i is 15i, 3i times 2 is 6i, and then 3i times 3i is plus 9i squared. So I'm going to go ahead and combine my imaginary pieces to get 21i. We know that I squared is really -1, so that's 10 plus 21i minus 9. 10 minus 9 is 1 plus 21i. Okay, and then to finish this, I'm just going to take my new denominator and write that over my new, what did I say? Did I say denominator? Sorry. My new numerator, my bad. My new numerator over my new denominator of 13. So this right here is what happens when you divide those complex numbers. Okay? So as you see, when I know I said division, but did I really do any dividing? No, I really just multiplied twice. All right, let's do B. Now this is a little tricky. If you wanted to help you with B, you could write 0 plus 5i. So when we multiply here by the conjugate, right, multiply the top and bottom, you could write 0 and 5i and do the opposite sign, which would be 0 minus 5i. Now you really don't need the 0, it's not going to do anything, but make sure you know that when it says 5i there, the conjugate would be negative 5i. Do that to the top as well. All right, so multiplying my 2 on the bottom is going to be 5i times negative 5i, which is going to be negative 25i squared. We know I squared is the same as -1, which is positive 25. Again, not surprising, we got rid of our imaginary piece. Let's multiply our two numerators. Sorry about that. All right, times negative 5i. So 2 times negative 5i is negative 10i. 9i times negative 5i is going to be minus 45i squared. Bring down the negative 10i. I squared is negative 1. So it becomes negative 10i plus 45. Please write that with the real number first. So 45 minus 10i. Put them together, my new numerator over my new denominator. Now this is the answer, but what you can do is when you do these problems, take a look at the 45, the negative 10, and the 25 to see if you can divide all of them by the same thing, and you can. Those are all divisible by 5. So if I take all three of those coefficients and divide them by 5, I get 9 minus 2i over 5. So this is what I'm looking for like the simplified answer. All right, so always before you move on to the next question, see if you can divide all three numbers. Got to be all three, guys. All three numbers by the same thing. Okay, I think there's 2 more left. Let's do C. All right, so I see 5 plus 4i. So I'm going to multiply times 5 minus 4i, top and bottom. So doing my denominator here, which is going to be 5 plus 4i times 5 minus 4i. Again, we know the middle pieces will be gone, so 5 times 5 is 25. 5 times negative 4i is negative 20i. Then 4i times 5 is positive 20i, there's that 0. And the last 2 is going to be negative 16i squared. So 25 minus 16 times negative 1, which is really 25, plus 16, which is going to be 41. So that's my new denominator. Multiply 7i times 5 minus 4i to get 35i minus 28i squared. Cannot leave that alone because we do have an I squared, which is the same as negative 1. So 35i plus 28, written in the correct form of real number, and then imaginary term, and we're going to bring that down and write the answer. So 28 plus 35i over 41. I don't think we can divide all three of those numbers by anything, so I'm just going to leave it like that. All right, last one, and then we'll be finished. All right, so multiplying by the complex conjugate of that denominator. Remember, you write down the negative 1, you write down the 2i, but change that middle sign to be the opposite. So again, nothing changes except for the sign in between the two terms. So do that same thing to the top. So negative 1 minus 2i times negative 1 plus 2i. That's going to go ahead and rationalize this denominator. So negative 1 times negative 1 is 1. Negative 1 times 2i is minus 2i. Negative 2i times negative 1 is plus 2i. And negative 2i times 2i is negative 4i squared. Bring down the stuff that doesn't make 0. That's going to be 1 plus 4, and you get 5. Okay, multiply my numerators. 3 plus 11i times negative 1 plus 2i. Distribute. You get negative 3 plus 6i minus 11i plus 22i squared. My imaginary pieces are going to become minus 5i. I squared is the same as negative 1, so that's negative 3 plus 5i. Let me make this look like an I. There we go. Minus 22. Negative 3 and a negative 22 is negative 25 plus 5i. Put those together. So negative 25 plus 5i over 5. Again, if I'm looking at this number, my coefficient there, and my 5, all three of those can be divided by 5, which is going to give me negative 5 plus I. And you can write over 1. There's no need to write over 1. That is going to be our simplified answer. All right, so that's how you do multiplication. That's how you do division. Good luck on the homework. Come see me with any questions.